guys, so we're going to, I don't know if I can zoom in on that. Oh, I hate that about this program. We're going to go ahead and get this last two little lessons out of the way. And the first one, I can get everything to focus. There we go. Solving with imaginary roots. We're going to be solving equations now. And there's two ways that we're going to learn how to do it today. Or there are two ways that we're going to learn how to do it in this unit. The first one is by taking the square root. And the other one is going to be using the quadratic formula. And I'm pretty confident that you've already seen both of these. So again, this is just more review. I put the standard up here at the top. It's just telling us that all we're doing is finding complex solutions. That means there's going to be a real and an imaginary part. And it's by taking the square root. We are not going to complete the square. It's not required. And quadratic formula. So square roots and quadratic formula. So when you're solving a quadratic equation, the things that you're looking for can be called solutions, roots, zeros, because that's where they cross the x-axis. That's where your y value is 0, or which is also your x-intercepts. Okay, so those four words are interchangeable. Solutions, roots, zeros, x-intercepts. They all mean the same thing. I'm looking for the answer. So if you have an equation that looks like this, you don't have a linear term. That plain old x is not in there. You have a quadratic equation that's just got the quadratic term, the x squared, and the constant. We can solve that using square roots. I'm going to show you. You already know how. I'm going to remind you. Alright, so looking at the first one. The object here, let me go ahead and put it this way. The object here is to manipulate it so that it looks like this. We want to get the constant on one side, the square on the other side, the quadratic term on one side, the constant on the other. So if it doesn't look like that, you need to do whatever inverse operations are necessary to make it look like that. And these are really difficult to see. See if I get, yeah. It's on your paper, and I know you can see it on your paper, but I know it's easier too for you to know what's going on if you can see it on the notes. So for the first one, the quadratic term is on one side and the constant's on the other, but the quadratic term is not by itself. And so we're going to divide, if you're multiplying the v squared by -3, we're going to do that inverse operation and divide by -3. So I get v squared is equal to -16. And now it's set up where I've got the quadratic term on one side and the constant on the other. The inverse operation for squaring a term is to take the square root. So if I take the square root of v squared, that gives me v. When we're doing solutions, we got to remember this plus or minus part, because you can get a positive answer, you can get a negative answer. And the square root of -16, because it's got that negative in there, we know we're going to have an imaginary answer. So the square root of 16 is 4. And the square root of -1, the negative portion here is I. So my answer is plus or minus 4I. Okay, easy stuff. Number 2, if I add 1 to both sides because the quadratic term is not by itself, do that inverse operation that's going to get rid of the -1, and I have x squared is equal to -4. To get the square root, to remove that or to undo it, to remove the square, we do the square root of both sides. And so x is going to be equal to, you got to remember the plus or minus, because you can have a positive answer. If you square a positive answer, you can take the square root of it. If you square the negative answer, you can still take the square root of it. So the square root of -4 is going to give me plus or minus 2I. Okay, easy stuff. Number 3. I've got -x squared equals 432. So my operation to get rid of the multiplying by -9 is to divide by -9. And 432 divided by -9 gives me a -48. So now when I take the square root of both sides to get rid of the x squared, I get x is equal to plus or minus. Now here's the thing, I don't mind if you use your calculators for this, because if you're doing square roots, you can do the square root on the calculator, you just can't do the negative part. So you just have to remember to put the I in your answer. So when I take the square root of 48, because it's not a perfect square, we're going to have to simplify it. If you'll just use your calculator and let it do it for you, we can see that that's 4 square roots of 3. So my answer is plus or minus 4i times the square root of 3. You just got to remember, if you're taking the square root of the negative, to put the imaginary stuff, the imaginary part in your answer. And when you take the square root, you've got the possibility of it being a positive number or a negative number. Okay? Let's leave the last one. Number 4. I've got x squared plus 3 equals negative 12. So I need to get rid of adding 3 to the x squared by doing the inverse, which would be to subtract 3. And so I get x squared equals negative 15. And then I'm going to do this inverse operation to get rid of the x squared. If I take the square root, I'm going to get x is equal to plus or minus. And if you put the square root of 15 in your calculator, if you're not sure about it, you get the square root of 15. So it's not going to simplify, but you got to remember that's a negative 15, so we're going to have an I, and we've got the square root of 15. So pause the video right here for just a minute and do the 4 at the bottom, and then check them and make sure you got it right. So pause the video for a second if you need to and check these answers. If you're not sure about how I did something, ask me, let me help you with it. But see if you got the answers I got. If you did, congratulations, pat yourself on the back. This is an easy lesson.